Well, I wrote a book called We Need to Talk About Kelvin, which is about what everyday things tell you about the universe. So tonight, for the show, I thought I'd just pick one simple thing, one everyday observation, which is you can see your face reflected in a window pane, and I would tell people what that tells them about the universe. In fact, it tells us that, well, it tells us some interesting things. It tells us the universe is fundamentally unpredictable, fundamentally random, and it also explains where all the complexity of the universe came from. It came from the injection of randomness into the universe by countless quantum events since the Big Bang. So I thought it was quite an amazing thing that you can actually deduce simply from the fact that you can see your face in a window pane. Undoubtedly, it's the Higgs particle. We're not quite sure whether it's been found or not. What we're told is there's a hint. Remember that the Higgs particle explains why the other particles have mass. Incredibly, after 350 years of science, we don't know the answer to that incredibly basic question: why is a fridge difficult to budge? You know, why? And Peter Higgs in the early 60s came up with this idea that the whole universe was filled with this invisible, what we call a field. Imagine it as kind of invisible treacle. This is the Higgs field. So when you try and push your fridge, you're trying to push your fridge through this treacle, and that's why it resists. And the Higgs particle, in quantum field theory, the fields can have localized kind of little hummocks, and that's what the Higgs particle is. I really think it will be something to do with extrasolar planets. I think since 1995 we've discovered more than 700, and they've been found at a rate of several a day. And even 2 days ago, I mean, we're in December 2011 now, there was an announcement that there were 2 planets found that were the same size as the Earth. Now, the techniques we use for detecting planets around other stars are sensitive only to really massive planets like Jupiter mass. So, you know, to get a very small one, that's a great achievement. These planets are not, they're too close to their sun. The temperature on the surface, I think, several thousand degrees. But I would say that very, very soon we will find a planet in what we call a habitable zone. It will be an Earth mass planet, and it will be at a distance from its sun that there can be liquid water. And I think not long after that we will detect the signs of biology. And so I think that would be a fantastic story. Could happen next year, could happen, it certainly will happen in the next 10 years. I would design a telescope that could actually image a second Earth, because I'm not sure that I'm going to be able to see that in my lifetime. At the moment, pretty much all the planets that have been discovered indirectly. I mean, when the Earth goes around the sun, it tugs on the sun, and the sun tugs on the Earth, but the Earth has a small tug on the sun. And this is the way in which we've detected planets around other stars. We've looked at a star and we've seen it tug slightly one way, tug slightly the other way, and we've inferred the existence of planets. We will probably be able to detect on a planet that we find maybe the existence of oxygen, methane, which are biological gases, but we're a long, long way from imaging a planet. The principal problem is that the central star is many billions of times brighter than the planet. So we need a way of screening out the star, and then we would need a very large telescope. But it would be wonderful. I mean, that will be one of the great images in the history of science. I mean, you know, remember the Earth rising above the moon, the picture of the DNA spiral. To see another Earth will be a pivotal moment in human history.